All right, this is the example on slide 18 of our chapter 21 PowerPoint. This chapter is all about radioactivity and nuclear chemistry. So the question here, they're wanting us to write the nuclear equation for the alpha decay of radium-224. So the strategy for this is to write an incomplete nuclear equation and then figure out the numbers that we're going to need, a mass number and an atomic number, and then from that we can figure out the mystery element symbol that we're forming. So remember, an alpha particle, when something is undergoing alpha decay, one thing that's being formed is a helium nucleus. Hopefully, if you've been following along the PowerPoint, you'll see that an alpha particle is represented as 4/2 helium. Now, remember our basically atomic symbols that we learned way back in the first semester. Let's do a little refresher on that. So, atomic symbols or isotopic notation is generally in the format A/Z next to X. And A is representing our element mass number, which is the number of protons plus neutrons. Z is equal to the atomic number of an element, and that's equal to the number of protons. And then X is just our element symbol. So for alpha decay, for alpha particles, the 4 represents the number of protons and neutrons this particular element has. The 2 tells us that it has 2 protons, and the He tells us that it's a helium atom. So you can figure out technically the number of neutrons by subtracting the atomic number from the mass number and coming up with the number 2. That's the number of neutrons we would have. All right, so that's a little bit of a refresher. This radium-224, that 224 is telling us its mass number. The 224 is what we write after something that's an isotope to indicate its mass number, which if we subtract the atomic number, we can figure out number of neutrons something has. So the first step for figuring out this reaction is to write the element symbol of our reactant. That's our radium-224. So it's going to be 224 on top. Now we have to figure out what its atomic number is. And thankfully, we have a very useful tool for that. If you guys will reference a periodic table, it could either be in your textbook or one you look up online, we need to figure out how many protons radium has. So if we look at our periodic table, radium is, let me go back to the slide that I was referring to. Radium's atomic number is 88. So it's way down at the bottom in the second column near francium. It's technically an alkaline earth metal. So 88 is the number of protons it has, so that's going to go on the bottom of the symbol we're writing. And then next to these two numbers is just radium's elemental symbol. So when that undergoes alpha decay, that's the only reactant, and it's reacting to form some element, we don't know yet, plus an alpha particle. So what we have to do is use the numbers that we have, the elements that we know, to figure out what else radium is forming when it's undergoing alpha decay. So basically, for this type of problem, the top numbers on either side need to add up to the same number, and the bottom numbers on either side need to add up to the same number. So we need to have 224 mass number on our reactant side, and the two elements together on our product side also need to add up to 224. And then for our atomic number on the reactant side, it needs to equal 88, And on our product side, these two elements together need to equal 88. So the way we're going to figure out the numbers for our mystery element symbol, so we're going to take 224 and subtract 4 to figure out what other element we have in the mix. So 224 minus 4 gives us 220, and I can do the same with the bottom number. 88 minus 2 is going to give us 86. So now we know the two symbols, or the two numbers, the mass number and the atomic number of our mystery element. So this guy has 220 mass number and 86, sorry, that's a bad 6, an 86 atomic number. And if you see, 220 plus 4 gives you 224, and 86 plus 2 gives you 88. So now the only thing left to do is figure out what the heck this element is. We can do that by consulting its atomic number. So this element has 86 protons. If you go back to your periodic table, figure out the element that has an 86 written above it, and you'll see it's all the way over in the noble gas column, and it is radon. So that is the element that radium basically decays into when it emits an alpha particle. So your complete balanced nuclear equation, 224 over 88 radium, forms 220 over 86 radon plus 4 over 2 helium. And that is your final answer.